So thank you all for coming. It is about 5 o'clock, and our speaker today is Professor Ken Anderson of Computer Science. Let me introduce you to the gentleman in the orange shirt in the back of the room. Yes, and they're being blocked, of course, by your colleagues who are standing in front of him. Well done, gentlemen. This is Dr. Dale Hatfield, and Dale was one of the founders of ITP many years ago. It is part of his vision that there should be an interdisciplinary telecom program, and he is on board with the new name, which is TCP, Technology, Cybersecurity, and Policy. And so please acknowledge and recognize Dale Hatfield, who has transformed many things here, and we are very, very thankful. And thank you for coming, sir. But let me tell you why you're really here. Why you're really here is because you want to hear about crisis informatics. And Professor Ken Anderson of Computer Science, also Associate Dean of the College of Engineering and Applied Sciences, he has been thinking about issues involving crisis management and what that means. And it seems to have some intersection with policy, some intersection with data, some intersection with cybersecurity, some intersection with, and oh, by the way, what do you do in the case of an emergency? And Ken is going to tell us exactly what we should do in the case of emergency. So please welcome Professor Kenneth.
All right. Thank you very much. And can you hear me in the back? Is the mic working? Let's see. Let's make sure that's working. Hello? Testing? How about now? Is that working? All right, it's on. Testing, testing. All right, that's there. All right, how about now? Good? A little better? All right, we'll try there. Okay, so yes, thank you so much for welcoming me today. I'm going to be talking about a research area that I've been working on now since 2010 called Crisis Informatics. And it's a great research area because it's reflective of just engineering in general. Engineering is always tackling really hard issues that have an impact at a societal scale. And so what crisis informatics as a research field looks at is society's response to mass emergency in the era of social media. So I'm looking at questions of how has social media changed our ability to respond to mass emergency situations. And so I've been working in this area since 2010, but my colleague, Professor Laisha Palin, helped to found this field, start this field back in 2006. And she was looking at how people responded to Hurricane Katrina. And at that time, in 2006, it was just before cell phones really took off in the United States. And so Hurricane Katrina was interesting in the fact that there were several locations in the southern United States where people had come together in shelters and had to stay in those shelters for quite a long time. Not all families ended up in the same shelter. So there would be some families that were actually separated by hundreds of miles in these shelters. And she took a team down to go look at what they were doing, and what they were doing were creating message boards saying, I'm looking for so-and-so, here's a picture, or I'm looking, I'm here, if you see this person, please let them know I'm okay. And they were basically doing things that they now do online. And she noticed that there were visitors that would be rotating among the sites, so they were parts of government organizations or NGOs, Red Cross and the like, who would come to the message boards and see some of those messages and take pictures of them and then go around to other sites and let people know about what was going on. And so what we've done is to look at how society now does these sorts of things, checks in on an event, verifies that someone's okay, collaborates to help people in need through social media. And that led to the foundation of something called Project EPIC, which is the research project here at CU Boulder that examines and studies this societal response. And so in crisis informatics, we need a whole bunch of data, and I'll talk a lot today about how we collect that data because social media data is hard to collect. We needed to develop research methodologies so that, let's say you have a data set of, for instance, our Hurricane Sandy data set is 220 million tweets. How do you actually go about studying something that has so many individual data points? And we had to develop a bunch of software tools that would help us do that. Because as kind of an early reveal, teams of researchers on Project Epic can really only go dig deep into several thousand tweets. So when we have a data set of 220 million tweets, we have to develop a set of research questions, use those research questions to filter and sample that data set down to thousands of tweets, and then humans can go and comfortably look at every one and annotate and answer questions. And now over the course of this time, we have run into very interesting policy issues. In particular, the thing that we study the most is Twitter. And so we've collected lots and lots of Twitter data. And people can choose to geotag a tweet. And so when they do that, we know almost right where they're standing. And if they have a photo, we know where they were looking. And if they're young, like one person was in our early data sets who tweeted about every 3 minutes, we knew where he lived. We knew how he got to work. We felt after a while of observing this person like he didn't go to Starbucks one day, like reaching out to him and saying, hey, you didn't go to Starbucks like you normally do. What's wrong? That wouldn't be creepy at all. And we had to start reflecting on, we have all this data. It's freely given. In fact, our institutional research board here at CU acknowledges that Twitter data is in the public domain. We don't need special permission to gather it. We don't need special permission to study it. But there are ethics involved in terms of reporting on it. So we have to be, as researchers, ethical in what we choose to report, how we aggregate the data, et cetera. And so that's where we've run into some policy issues. So what I'm going to talk about a little bit at first in this talk is just kind of the software infrastructure we developed to collect all this data and some of the issues that we encountered there. But at the end, I'm going to come up with a slide that talks about some of the policy issues and steps us through some of the ones that we've wrestled with. So just a little information about myself. I'm Professor Ken Anderson from the Department of Computer Science. My area of research is in software engineering, and in particular how you design and develop large-scale data systems, big data systems, how we make them reliable, efficient, and scalable. The kind of big data is kind of the marketing term, and what you'll see in the research field is data-intensive software systems. And so I lead a team of software engineering students that look at these issues, and we've developed many prototypes over the years. And as I mentioned, we do this in the context of Project Epic. Over the years, it's received 2 or 3 grants that total about $4 million. We've collected data on hundreds of events. We have about 2 billion tweets that we've collected over time since starting in fall 2009. This number, I just realized, is out of date. We're up to about 90 to 100 refereed conference and journal papers. Some of those are about the software infrastructure and the design issues, just pure software engineering papers. But the vast majority are about the issues that come up when examining this data. What are people actually doing in these events? How do people collaborate? How do they share data? Can we trust this data? We'll look at issues of trust and the like. And it's generated about 7 to 8 PhD dissertations over time. So it's a very fruitful area of inquiry. And EPIC stands for, it's an acronym for Empowering the Public with Information in Crisis. And that was one of the things that that made us kind of unique when we started, was this focus on the members of the public. Because at the time, there were a lot of people that were doing grants on emergency management, but they were all focused on the first responders, the firefighters, or the members of the Red Cross. And they were focusing on those people. And we were looking more at just any person that's out and about when a disaster happens. And one of the reasons why we focused on that was there was more data available. If you're working with firefighters and you actually want to change what they actually do or change the equipment that they do, you're talking about years of of development and then testing and more testing before it would ever get approved to actually be used in the field. And so there's a huge number of research topics, and we'll touch on a few as we go forward. Now, why this focus on members of the public? And the answer is that things really changed after 2006 in the US. And of course, we were about 10 years behind Europe and 10 years behind lots of other places in the world. But it was right around 2006 and moving forward where cell phones started to be more broadly adopted by the US. And the world in general. So in 2005, I love this photo. This is a photo of people in Italy standing in a plaza, and they're waiting for the announcement of who's going to be the next pope. And in 2005, if you look right down here, there's one person with a flip-style cell phone right there. Otherwise, people are just, what did they do before cell phones? I have no idea what they were doing, but they're apparently just standing there talking to each other. And within, 8 years later, people gathered at this same plaza for the announcement of the next pope. And they were waiting, and this is what it looked like. So in 8 years' time, it's hard to point at someone who doesn't have a cell phone or a device. This person's holding a laptop. There's actually a great picture. There's a great picture of Obama giving a speech in Germany, and people are holding up laptops because they're live streaming on their blog what he's saying. So this is what's happening. And so think about this now. If a disaster occurs or some major event occurs, all of these people become reporters. They can all take a picture and say, I saw this at this time, and here's what the situation was. And you often don't, and there's more than 100 years of disaster sociology research, so sociologists have been studying disaster for a long time, that says that people are more altruistic in emergency situations, they're less prone to lie or tell mistruths. The members of the public are the true first responders, right? So when a firefighter shows up, they're late to the scene. People already there are helping people in the situation. And so these are the true first responders. And the fact that they're all reporters now makes emergency management just that much more interesting. And what happens when everyone has this sort of access to technology, pervasive access to technology, is that you start to see what's called collective action. Because now we have the tools for people to act as one. And in the 2010 Haiti earthquake, this really came through the use of a system known as OpenStreetMap. Now, OpenStreetMap, if you've never used it before, its catchphrase is, we're the Wikipedia of maps. Meaning, so in Wikipedia, theoretically, anyone can go to a page and edit it and change that page. Of course, the edit's usually rolled back within milliseconds, but you can actually go in and make the change on Wikipedia. Well, the same thing is true in OpenStreetMap. You can create an account at OpenStreetMap, log into the map, and start editing buildings, changing roads, everything you want. And so the reason why your edits are typically rolled back in Wikipedia is that over time the community has established quality guidelines. Maybe you didn't follow some standard. We want to roll that back, discuss it, and then we'll roll it forward with whatever meets the community guidelines. And OpenStreetMap is way behind Wikipedia in terms of what the community guidelines are. But this has been used now for what's called crisis mapping for many, many events. And in fact, 2010 with the Haiti earthquake was one of the original crisis mapping events. Because what's really cool is they only use, all this data is freely available for use. So it's open licensed. It's not proprietary in any way. But when a disaster happens, companies like Digital Globe, which is located just down the street, by the way, in Longmont, when a disaster occurs, those companies which have satellites and are taking pictures of the planet all the time, they will typically donate their most recent satellite image to OpenStreetMap so that people can use those images to then map what happened after an event. And so that's exactly what happened in Haiti. Digital Globe and a few other providers had, sorry, let me set this up right. OpenStreetMap, this is what the map was of Port-au-Prince before the earthquake happened. And this, if anyone who looks at this who knows about mapping would say this is a pretty low quality, poor quality map. There are only a few major thoroughfares that are mapped. There's a couple of these smaller roads, but not much in there. And of course, the international community was about to converge on Port-au-Prince. All these responders, everything from first responders to military organizations to Red Cross, Doctors Without Borders will fly people in, and there was no map. So what they did was they donated satellite imagery, both before the event and after the event, over to the OpenStreetMap community, and about 600 people came together, and in about, I think it was less than 5 days, maybe it was 10, they turned this map into this map. And so this is people taking a high-resolution satellite image and going into the map at this location, for instance, and tracing all the buildings they see. And the software OpenStreetMap has that ability to just place an image over their existing map and then just to start tracing things that you see on the map. And then when you click Save, it updates the map. And so they produced what is considered now the most comprehensive, detailed map of Port-au-Prince at the time. It has since, because the international community's attention no longer is focused on this place, it is now starting to get out of date. Actually, we have a paper that talks about that, where there are still buildings that are marked as destroyed that have since been rebuilt. So not as much attention is being put on it. But during that intense period of time, the community came around, and none of these people were paid for this. This was all volunteer action. Which is really kind of an interesting thing to see. And now this happens all the time. There's something called the Humanitarian OpenStreetMap team, where when an event occurs, and it could be anything from a political event, a mass convergence event like the Olympics, for instance, or when we had the earthquakes, for instance, in Nepal a few years ago, the earthquakes in Japan in 2011, the community is ready. You give them the images, they're ready to come in and do before and after mapping of the event. So this is the type of thing we like to study. Like, what motivates these people? How does this produce maps like this where we can say this is of high quality, and the like. So in our day-to-day life, it's unfortunate we say, we study disaster and it doesn't take very long for another disaster to happen. So in our day-to-day life, what we do is we focus on events. We wait for an event to happen. When an event happens, we start to monitor events in TweetDeck. And we start to identify keywords that, one, will cast a wide net. So if what we're monitoring is an earthquake, we have earthquake that we're searching on. But we'll start to also add in regional terms. What are the names of cities or villages or small townships or counties that are in that area? Because those, if there's tweets with those terms appearing, those are locals that are using those terms. And so then you can start to study, and we have, the difference between a local tweeting about an event and someone who's just watching the event from afar. And we will also put in multiple languages. We'll try to find people who speak the language in that region, and they'll translate terms for us, and then we'll add those terms to our search. And we will update keywords as needed throughout the event. And so we typically will have a couple PhD students that will do this, and they'll monitor the event and hand off to each other as we go through. And collection can be very long-term. Once we've started an event, we can, typically events have lots and lots of tweets right at the beginning, and then it starts to trail off, as one would expect. And in this particular case, what we wanted to do was to look at anniversary type behavior. So here was a spike on an anniversary of this event. And since it didn't cost us anything to really turn off this event, we just let it run. And some of our students are now looking at longitudinal studies of these things. How has people's response to an event changed over the years through their tweets? So just to make this a little bit more real, this is where kind of my software engineering side comes in. The first thing that we do on an event is what's called keyword collection. And so we identify these keywords. And when you give this to Twitter, you hand it to their streaming API. And the streaming API will start sending you tweets. Tweet, 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 tweet. And all these yellow ones are tweets that contain at least one of the keywords that we asked for. But if you were to restrict your research just to this, you're only seeing those tweets that have those keywords. And what's happening, of course, is each of those tweets were probably generated by different users, and they're just one tweet in that user's timeline, right? And what we started to realize was that they would mention one of our keywords here, but then keep talking about the event. but not use our keywords. And we weren't getting those tweets at all. So kind of to visualize that, you had this kind of contextual tweet. They're talking about the event. Here they use our keyword. They're talking about the event here, et cetera. And where our research really started to produce results was when we could capture all of these tweets. And so what you have to do, Twitter has a limit on its public APIs as to how far back in someone's timeline you can go. And that is 3,200 tweets. Now, for many people, that's all their tweets that they've ever generated. But for many people, it's not even close. Like, there are people that tweet, thousands and thousands of events over weeks. And so if you don't go back and collect all those tweets fairly close to the event, you'll actually find that, you'll start collecting their tweets and you'll get back to like here. And you missed all of this part of the event because they were just tweeting so often. And so there's various things that we've had to do over time to come up with better techniques for that. And so we call this the contextual collection, in which we're not only getting the keywords, but we're building up a context around the event. What are people talking about? And when we get to policy at the end, I'll return to this issue about why this is so important. We're one of the few research groups that does the work to build up these contextual data sets. One of the things that we're starting to do now with some of the premium APIs that Twitter provides is we are, for certain types of events, we're seeding the users that we're interested in. So, for instance, in hurricanes, in a particular region, we work with meteorologists who know who the primary meteorologists in that region are. And so we add their usernames specifically to our search. We add in things like Channel 9 News of the area that was impacted. And so we try to get a bunch of what are called authoritative reports, authoritative accounts that are included alongside the members of the public. But then what we do special for them is we try to find all the tweets that have replied to their tweets to build up a conversation so that as they talk about something, they're reporting on something, if something's interesting and the community starts talking about it, we start capturing that conversation as well. So this idea of events being conversations we'll return to. And then just to give you a sense of scope, here was Hurricane Sandy. And one of the things we did was we looked for people who had tweeted a geolocated tweet in the path of the storm about 24 hours before it landed. And Hurricane Sandy was one of those hurricanes that kind of went up the coast and then came in onto New York. And then we went and collected all of their tweets for the people that did that. And then we plotted all the ones that had geolocation, and that's what this image was. And I took this screenshot about a millisecond before Google Earth died on me. But you can see, I mean, there's so many geolocated tweets here where the landfall occurred that it's just gone white because it's drawn so many things in one spot. But this gives you a sense for, you can map, and we have on some events just mapped the entire globe of people talking about an event, and you can see that sometimes you'll see very interesting things where an impacted region is known to have people from different parts of the world that have resettled there. And so then you'll see their homes, the people where their families are in those countries tweeting about the event as well. Because they're monitoring, is my family okay? What's going on? I need information, etc. So let me just talk, because I'm a software engineer, let me just talk a little bit. Let me just talk a little bit about the software engineering work that we did, because this was really my entree into the big data world. Before this, I had built lots of software systems, but none that were designed to run 24/7, collect billions of tweets, terabytes of data, etc. And so the key takeaway that can describe my experience moving into big data is this word. Failure. And this is where, when we say we're doing research where we don't know what the answer is, this is what you get when you don't know the answer. Lots of failure. Let's try this idea. Nope. Let's try that idea. Nope. This idea. Nope. And that's something that's cool about engineers, is that we don't let that stop us, right? We learn from failure. We're resilient. We move on. So in fact, actually, our motto is embrace failure, because you tried something, it didn't work, you just learned something, and now you can move forward in your study. And so let me just kind of tell you a little bit about our journey. When people first come to collect tweets, a lot of people will use this little command line tool called curl. And it doesn't take very long. You just have to figure out exactly what API endpoint you need to hit on Twitter. So this is the streaming API, version 1.1. You have to do a post request. So there's some setting up of the configuration parameters, and then you just pipe into a file, tweets.json. Good, right? Done. Data collection's done. No. That is not what happens at all. Because, for instance, let's say you started this on your laptop. Well, now you close your laptop. Now what happens? Connection dies. Oh, I want this to run while I'm not on my laptop. How do I make that happen, right? So this approach here is not scalable, it's not flexible, it's not sustainable. And when we started doing this, building our systems in January of 2010 in response to the Haiti earthquake, it was the start of 2.5 years worth of work till we finally got to a point where we had a system that would run 24/7, and I could stop worrying about data collection. So in those 2.5 years, my life was waking up at 3 a.m. and logging in to see if data collection was still running. And if it wasn't, starting it up again and then going back to sleep. Really, really sucked. So you have to learn all the different software engineering techniques. And as programmers, when you first start learning programming, they don't tell you about any of these programming techniques. So if you're just downloading to a particular laptop, you have to realize that the program needs to run longer than the laptop, its use. So if you close the laptop, it goes away. So you go, oh, I got it. I just need to start the program over here on a server. So I'll log into the server, start the program there, and then of course I'll log out. And then of course what happens when I log out, the shell kills everything and your program's not running. So you're like, okay, well, that means what I'll do is I'll start the program and put it into the background. There we go. And now I'll log out, and then the shell still hopefully kills all your programs that were in the background because you logged out. So that's not going to do it. So eventually you'll learn about things called screen. This is one of the tools. They're called terminal multiplexers, where you basically can log into a terminal, start a program, and then detach from that program so that the terminal thinks it's still running, that a human still sees its output. And then because it thinks that you're still connected, when you log out, it'll actually stay running. And this is the magic words. You say screen-s and you give it a name, and then once you're connected and things are running, you do Control-AD, and that detaches away from the screen. So that allows you to log out, but then all sorts of things can happen. The network connection to Twitter might go down. You might have had a database and it run out of disk space because you're doing millions and millions of tweets. So you're still not out of the way. So maybe you'll use relational databases, have it be on its own server, not worry about disk space any longer. But as soon as you pick a relational database, you have to pick a schema. Right? So you have to say it's going to be, my table has this column, this column, this column, this column. Well, Twitter, if you look at the JSON object that it sends you, has about 300 attributes on a single tweet, and they love changing those attributes. So attributes come and go. Data types change. I've seen things where, like, it used to be retweet count. It was really cute. Retweet count was a string. It was an integer from 0 to 99. And then when it got to 100 or more, it changed to a string that said 100 plus. And so if you go back in time and search on those tweets, you have to be ready for the response that comes back from that field to be either a string or an integer. Then Twitter wisened up and said, a tweet could have millions of these things. We better just stick with integers. So you have to know how these attributes all change. So the problem is any schema you pick for your relational database is eventually going to get out of date, because the attributes will change in some way. They'll come, they'll go. And you really don't want to be in a situation where you have to migrate every time Twitter changes its mind about the attributes. And so if you do that, you'll make choices like, oh, well, we'll just do text, and we'll do the username and their screen name and create a dat. We'll just pick a few, and then that's all we'll need. And then, of course, your data science team will go, no, I needed the URL, I needed the media URLs, I needed this, I needed that. Where's my data? Oh, we were throwing that away. Sorry about that. So you can't do that. And so, yeah, and then, of course, you have been fooling around with, say, wildfires or flood events, and those are kind of small. You only get 10,000 tweets or so. And then you do something like the Japan earthquake, where you have like millions of tweets in the first 3 days. And so Twitter does a surge on you, and your system goes, what? And everything goes down because you weren't ready for the scale, the velocity of the data. And so as you can see, just by stepping through these things, everything that I described, we had to learn the hard way. Oh, that's not going to work. Oh, no, they want all the data. And oh, we weren't ready for 100 tweets a second, 200 tweets a second that happen when you have these big events. So failures are hiding everywhere. And of course, that means data collection is stressful. And what you really want data collection to be is reliable, scalable, and efficient, and not think about it. And it's been nice. When we finally got our system for the Summer Olympics of 2012 in place, we turned that thing on, and it's been running ever since 24/7 for 6 years straight. If you think about it, when you go in to learn programming, CS1, CS2, CS3, your programs run for like less than a second, and they're really super small. And no one ever tells you, how do I take one of those programs and write it so that it runs for years? And it's a really different mindset, a different set of skills. So data collection really should be boring, happening in the background. So our path to success was to get the right data store, so that a lot of the logic is handled by the database itself. And you should not pick a persistence technology based on its popularity. So at the time we were doing this research, MongoDB was everywhere. You couldn't go 3 steps without tripping over a flyer about MongoDB. And it was supposed to meet all your needs, and it was just crazy with respect to its mind share. But we looked at MongoDB, and it did not provide the features that we needed. And we needed flexibility, we needed scalability, we needed availability, so that 24/7, if we wanted to write a tweet, the database was ready to be there to receive it. And if we needed to ask for tweets back, it was sitting there ready to give us the answers back. And we needed to be reliable, so that if one node went down, we had a copy somewhere else, we weren't losing data. And the winner for that at that time was Cassandra. And Cassandra was the winner for us because at the time, all we cared about was storing the data. We hadn't yet gotten to analysis. And once you have to go and analyze all the data that you've been storing, you might want to start, and we did, eventually start to pick different database technologies. But what we did was we spun those up alongside Cassandra, because Cassandra was just amazing at always making sure it was up and running. Any tweet we put into it was replicated. If any node went down, we could just replace that node, and it would copy from the replicas and get back to date, and so that we didn't have to worry about losing any data. And I don't have too much time to go into this, but I'll just give you briefly an overview of our architecture. We had basically a simple web service called Epic Collect. It had a web browser-based front end, where you could log in and say, I want to create a new event, and this new event will be called 2018 floods in Wyoming or in California, wherever it is, and then you start adding your terms. And once you finished adding your terms, you hit submit, and it stops the current collection, adds those new terms to whatever you were previously collecting, because we were collecting on hundreds of events in parallel, and then reestablishes the connection to Twitter and goes through and starts storing data. And as Twitter streams data to us, Epic Collect does a little bit of stuff with it and then puts it into Cassandra. And Cassandra, then we had 4 nodes, and it would just start to distribute the data across those 4 nodes and replicate the data, etc. If we ever wanted to add more nodes, then Cassandra would rebalance and put the data out there. We could ask it to do more replicas. If one dies, it would know where the backups were for all those tweets, put in a new node, it would copy it back over again. So really, this was the database taking on a lot of the work that used to be a headache for the developers, and really, really reliable technology. And then here within Epic, I won't spend a lot of time on this, but even this box here, I'm now showing you the insides of that box. We basically had a connection to the streaming API and a queue of tweets that needed to be processed. We had multiple workers that were pulling stuff off the queue. We had threads that were checking to make sure the workers hadn't died, and if so, would try to restart them. If it could find that all the workers were dead and it couldn't restart them, it would restart the process itself. So we had a whole bunch of things that are in there. So you're always monitoring your connection to Twitter etc. And so this means you're not doing simple single-threaded programming, you're doing multi-threaded programming, you have to deal with issues of concurrency, buffering, how much memory is the right amount of memory, what happens if a Japan-style event happens, do we have enough in our buffer to store all the tweets, because until the worker thread pulls it off the queue and sends it to Cassandra, we're in danger of losing those tweets that are sitting here in memory. And so you want to process them as fast as you can, you don't want to get behind, etc. And overall, we had a huge software architecture, and if you look at our papers in software engineering, we start to describe how we got to this architecture. So we had Epic Collect here and Cassandra there. We started spinning up databases alongside that would do things like, in this case, it would store annotations. We eventually did get to something called Epic Analyze, which was a Ruby on Rails web app that was sitting on top of technologies like Solr, Hadoop, Hive, and Pig. Pig was something that would allow you to auto-generate Hadoop jobs based on a high-level specification. We had Redis, which is an in-memory database, which is really fast queries. And so if we made a query that took a long time, we would store the results in Redis. And then if we made that query again, we would get the results right back. And so what happened here is this is kind of a textbook case of what goes on in big data software engineering. It's never one piece of technology that is going to save the day for you. And this is kind of where you see software architects and software architecture coming into play. It's what's the array of technologies and frameworks that we have to stitch together to make it all work. You know, so web-based app, third-party tool that wanted access to the data, databases, a middleware layer, lots of different systems. Each one of these, of course, had its own server, had its own data disk space that we had to allocate. So huge, you know, this thing here was, I'm showing this all in one box, but it was distributed across lots of machines. This was running on a machine with lots of memory so that we could store lots of things in it. And so you had to align the hardware with the software and what its purpose was, and pull it all together so that when an analyst is sitting up here in Epic Analyze and they issue a query, they can get a response back in seconds. And that took a lot of work to be able to pull off, just in case, you know, for instance, you have a data set with 220 million tweets, and they type a query. When they hit return, they want sub-second response times. Right? They don't want to be sitting around while a Hadoop job goes off and calculates for a day or so. So there was a lot of things that had to happen to make all of that work. And so this just gives you a sense for kind of the things that we want to do. And my takeaway for this is that big data really challenges you as a software engineer because you're typically used to things like centralization of your software. You have like one thing that runs. It's single-threaded. You're not using multiple threads. It might be in the context of interactive systems, so maybe it has a simple interactive model of I wait around until an event happens, then I respond to the event. In the relational database world, we're taught about schemas and how to normalize, you know, first-level normalization, et cetera. And then transactional kind of semantics. I will ask the database to make this change, and before I go on, I know the change was made, right? And more programmers are used to this, and this, right? Everything on the right-hand side of these comparisons. And everything about big data is the opposite. You have to handle distribution, parallelism and concurrency, batch processing or stream processing, no schema, and duplicating data. I don't even have time to talk about what I mean by duplicating data. And eventual consistency. So I'm going to tell the database, and eventually my queries will show me that result. Completely different way of thinking about these things. And so this just adds to the complexity of working in this field. Yeah, so this last one here, eventual consistency versus transactions, you can think about this as flight reservations, right? If I'm booking this seat, I want to know I have the seat and someone else doesn't. Versus Facebook likes, where a post loads in your browser and it says 20,000 people like this, and you click like, and it says 30,000 people like it. It's not that it's not like your like was worth 10,000. There's just a bunch of likes that happened in between, and it was just updating you on what the current like was. And then NoSQL, we use that term broadly to mean like the thing that's not, that stands in opposition to, not opposition, but kind of as another alternative to relational databases. But within here, there's like 7 different types of NoSQL databases. Right? There's columnar, there's map-based, there's graph-based, there's key value, there's, what's that other one? I'm drawing a blank. But anyway, there's lots of different types of NoSQL. And so it's not just like learning one technology on this, it's having to learn 7 different types of technology and when you use them, when you don't. So this kind of give you a really kind of fire hose introduction to what we do, the kinds of questions we ask, the types of technologies we have to put in place. And like everything I just described is what you kind of need to just begin asking questions like, what did people do to collaborate in Hurricane Sandy? Like you need all of that in place so you can collect all that data to then finally start asking the questions about what's happening in the environment from a social point of view. So now what I wanted to do is, for the seminar, kind of talk about some of the policy level issues that we've encountered. And I already alluded to one, which was having tweets that had geotags. And what do we do with that data? Because there are people in our data sets that show us where they live, how they work, etc. And we had to wrestle with that. We actually wrote a paper about that in terms of what we thought the ethical things were to do in terms of reporting, the kinds of merging that we would do. Like when we report tweets out, we never use people's real names, real screen names. They're always anonymized. We're usually reporting about aggregate statistics as opposed to an individual case. We do have one paper where we don't de-anonymize the tweets that we show, and that's because we actually interviewed the people that generated those tweets and got their permission to include it in the paper. But that's once in a blue moon. Normally we have to make sure that we're honoring the fact that even though it is public data, we're respecting their privacy when we report on it. Now the things I'm going to talk about in more depth is the use of Twitter by NGOs, non-government organizations like the Red Cross, and government agencies, and how we've seen that change over time. And I actually don't have any slides about that, so I'm just going to talk to it. And then I've got a few slides on location information, a little bit more. And what's really interesting is how things are changing with respect to Twitter data and geolocation. And then finally, I wanted to return back to what I mentioned before about events as conversations, because this is really a policy issue it's not traditional use of the word policy, but it's our guidance towards other researchers doing social media research in this space as to what we recommend you do in order to make sure you're getting good information out of your data sets. So on the first one, the initial reaction by both government and NGOs alike to Twitter was, we don't want to hear about it. Don't show me a tweet. Don't bother me about a tweet. I'm not going to trust anything that comes to me from Twitter. And that was their default stance. So they wouldn't look at it. They wouldn't let it bother them. And so they were just doing their work on a particular event without realizing there was a huge conversation going on online about the event and that people were coordinating. And in Haiti, we saw one person who actually, after the earthquake, had a satellite phone. Oh yes, Jim.
So what dates are you starting with and where are we now? So you said that originally no one was interested.
Right.
And then...
So this is back in 2010.
Thank you.
2009, 2010. There was a person in Port-au-Prince who had a satellite phone. And so even though everything was ruined, all the cell phone towers were dead, no one could connect to the local network at all, this person could tweet. So he's walking around and tweeting, showing pictures of devastation and that kind of thing. Gold mine of information. Everything he was posting was current as of the time of that post. Responding to questions, people would say, what's happening over in this area of the city? And he'd travel over there and show pictures. And then he says, oh, by the way, I have access to power, that's not my problem, but I don't have any money and I'm about to run out of minutes. So I'm going to go offline. And everyone on Twitter was like, what? No, you're like our best source of information. And so they actually organized a donation drive and bought him minutes to keep him online. And so that was like the gold standard of information on that event for the first couple of days. And the NGOs and government agencies, by policy, didn't want to know about it, right? And the reason was they're all worried about liability. Someone tweeted this, a building is burning here. If I send resources there and the building isn't burning, then I have misused government funds to respond to that event, and where the actual burning building was, I wasn't over there helping people in need. And so because of that fear, they did not want to engage in this data. And this lasted for many, many years. Some of the things that I'll talk about, Red Cross was one of the first that was open to Twitter data, but they didn't want it from members of the public. So what they wanted to do and what they started to do was to train up volunteers that volunteered for Red Cross already. They knew these people, they had trained them, they had worked in Red Cross events before, and now they trained them on social media. What are the types of things we want to know? What are ways in which you can verify, is this true or not? And then you can send us a summary. What are you learning from Twitter? And we've decided as an organization that we'll trust that information, not the raw tweets. And that was the same thing that started to happen for government agencies. I've got two stories to share on that front. One is with respect to the agencies that typically respond to wildfires. So wildfires will happen on the East Coast and the West Coast. And so what one enterprising young PIO, they're called public information officers, realized is that the wildfire seasons are typically offset. So if the fires are on the East Coast, they're not happening on the West Coast, and vice versa. So that means that their counterparts, public information officers on the West Coast, are sitting idle while they're busy every day with a fire on the East Coast, and vice versa. So they did the similar sort of thing, which is that they would, the people on the West Coast would volunteer to read Twitter and come up with what's going on about an event on the East Coast and send that to their East Coast colleagues, who would then trust the reports coming from them after they had been doing some training about how to vet information, what was true, what wasn't true. The biggest thing that happens, like I referred to the fact that disaster sociology tells us that most people act altruistically in these situations and offer truthful information. It's not so much misinformation, it's stale information. So there's very few instances you can point out where someone says, ooh, the building's burning over here and the building was actually building over there. Like you don't see that very often. It's like noise in the data. What you will see is the building is burning here at this time. And now three days later, it's no longer burning, but that tweet still says that this building is burning, right? It's just the information has grown stale over time. And so some of the techniques is to track information like that. And when I say track, I mean groups of people with spreadsheets saying, they said the building was burning. And then later on, okay, it's not burning anymore, right? And they go back and update that. And there actually was a group that emerged out of the Haiti earthquake called Humanity Road, and they were people who just volunteered their time to do this type of tracking and vetting of information. How many reports have we had on this? Can we call someone in the area to verify? You know, they start to do all that kind of stuff. And the people were so motivated and energized by what they accomplished in Haiti, they actually incorporated into an NGO themselves. And now they train people on how to do crisis tweeting. The other thing I'll talk about on the government side of thing was what we saw in Hurricane Sandy. The Fire Department of New York, so FDNY, has a Twitter handle at FDNY. And they're great. They're an excellent example of an organization that uses that Twitter handle for branding, building community, getting support for their services. But during Hurricane Sandy, all the cell phone networks went out in New York City. 911 went down. That's right, 911 went down, but people could still use Twitter. And so as they couldn't get through 911, and as the event was progressing initially, the people started to get desperate, like, we need help, and 911's down. So they started tweeting at FDNY, we need help here, please send this, please send that. And FDNY was fairly typical at the time. They're just like, sorry, we cannot take any requests via Twitter. We're sorry that you're having this problem. Please try to call 911. And we have lots of tweets of them, lots of interactions of them doing that at the start of the event. And then about, I think it was 8 hours in, 10 hours in, they're just feeling bad. They're like, all these people come to us. We can't get over they can't get through to 911, although Fire Department of New York did have access to 911 through other means. So then they start actually responding and saying, dispatch has been notified, that kind of thing, because they just felt like they couldn't watch these things anymore. They really were in a tough situation. And so what they've done is we've seen across the nation these types of organizations adopting policies now that will say when they'll take reports from Twitter, how many reports they need before they trust it, and those kinds of things. And so we have seen a real shift in how these agencies will start to use these things. All right, so now for location information, Geotag versus Georeference. Does anyone know the difference? Okay, so Geotag is when I tag my tweet, and what gets put into the metadata is my exact GPS coordinates. So that's a geotag. And as you know, to whatever resolution the civilian GPS system will give you, that's the resolution you get. And that resolution is really good, by the way. Military-grade GPS is supposedly 100 times better, but in the things we've been studying, I haven't seen a need for it. Georeference is I am standing in the city of Boulder. So the tweet doesn't have my geotag, doesn't say where I was, but I just say I'm in Boulder, right? And so likewise, I'm in Miami, or I'm in New York City. And you could do things like we could I think they've set it up, we could say I'm in the engineering building. And so then it would just be kind of a thing. And that georeference will have a geotag associated with the reference. So the city of Boulder has a geotag. And that means since the city of Boulder has about 100,000 people, there's North Boulder, there's South Boulder, there's East Boulder, there's the people that live in the mountains. And when we geotag to Boulder, all those different locations go to that one tag. So their tweet comes out, and it's not where they were standing, it's where the georeference was. And so this is a new thing. It used to be that you only got geotags, and then Twitter started to make it easier to do georeference. Facebook does the same things. What's the one that lets you do check-ins? Instagram. All of them have started to do this where they say, do you want to geotag your tweet? And they offer a list of things you could choose from. And that's a georeference as opposed to a geotag. And so what happens is you get, in this situation, someone who was tweeting right here in South Beach, Miami, but the tweet actually gets recorded as happening over here. And in one of the events that we studied where Miami had a lot of the data, you know, hundreds of thousands of tweets, everyone was standing right here in this exact location apparently. Big city, but they were all right there. No. And so the problem, of course, is that you then, if you're interested in how people, you know, if you're interested in spatial properties of people's behavior, georeferences, which are now way more common than geotags, obscure that information. You can't get access to it. So back in the day when we were looking at the person in San Francisco and we knew where he lived and how he took the BART into his job and all that kind of stuff, now all of his tweets would likely have just been georeferenced to San Francisco and we wouldn't know anything about him. And so you can argue that's a good thing, right? Now that person isn't unwittingly showing all aspects of his life, but it's a bad thing if, for instance, we're studying evacuation behavior, which is one of the things that we tried to do in Hurricane Sandy. So we've developed a whole infrastructure. We can get a huge number of tweets and we can map them. And we'll do things like this. This is displaying 3,184 tweets total. And of them, 1,798 are geotagged. And so if we don't know where the tweet is, it gets to its closest georeference, which in this case was here. But if we do know it was geotagged, then we show where it was tagged. And so what happens is if you have the geotags, you can do things like look at all the geotags of someone before an event, and maybe they were all centered here. And then Hurricane Sandy arrives, and they get the hell out of Dodge, and they come over here, and all their tweets during the event are over here. And then after the event, all their tweets are back over here. What's interesting about looking at this particular user is the person never uses the word evacuate in any of his tweets. Never. You couldn't just search on evacuate and find out who evacuated. People don't say that. Instead, they say things like, I'm charging my phone. Right? And that's because they know the storm's coming and want to have a fully charged phone. They don't know what's going to happen. We have other instances of people like that were in Manhattan before the event and then up in Connecticut during the event and then back again afterwards the event. And so what's happening is now with georeferences, the ability to do this type of research is going away because it's not like Twitter says, oh, here's the georeference and the geotag. They don't do that. They just give you the georeference. And so it's been very interesting. We actually can do more interesting work on location with our older data sets than we can do with our newer data sets. So it's an interesting thing. And so is this good or not, or bad? And this is kind of where a policy might play a role. Maybe you do want to have more accurate information for tweets during an event, and so maybe Twitter would want to adopt a policy, or the government could adopt a policy that says, hey, if we know there's some major event happening in New York City, let's turn georeferencing off so we have more granular data. We're actually seeing that with people before the georeference became a thing. We actually saw that people were becoming more savvy about their tweets. So they would turn geotagging off by default, but then they'd be in an event where they could contribute something, and that one tweet was geotagged. So they would turn it on because they know that someone could find use for that particular tweet. So we're starting to see more sophisticated user behaviors on that issue, and now georeferences are starting to obscure even that. All right, the last thing, I realize I'm almost out of time, is this event as conversations. And we love this tweet. It's our favorite tweet from the Hurricane Sandy data set. And Laisha Palin, my colleague, brought this up because, that's right, shit's out of control. Yeah. Shit is out of control. I feel like I'm going to see a deer flying in the sky. One of our favorite tweets ever. But Laisha Palin, in one of her, when she received the CHI 2015 Social Impact Award, she put this tweet up, and she asked, is this tweet useful? Does this provide any information? Do you know more than you did or not? And the point that she was making, I mean, the answer is no. It's like, I don't know what this guy's talking about. But the larger point was that if you look at social media research, a lot of it is exactly this, showing someone one tweet and asking you, is this useful? 9.8, 2.4, 3.7. I kid you not. They have Mechanical Turk. Up comes a tweet. Classify, yes or no, this is useful for this context or for this purpose, etc. And our point is the tweet is part of a conversation. If it's not an actual conversation between two people, you can think of the timeline of a user as a conversation with yourself. What is it that you're recording about your day? So this tweet is actually part of a conversation with himself, where he goes, people are really overacting about this damn hurricane. This is before Hurricane Sandy. I'm about to put my iPhone on the charger. Shit is out of control. I feel like I'm going to see a deer flying in the air, so the hurricane has arrived. Things are getting really crazy, 110 miles per hour, winds, that kind of thing. I'm about to make something to eat before the power goes out. And then finally, at Governor Christie, when is it safe again to head back home? Brigantine and Hurricane Sandy hashtags. And then finally, it feels so good to be home, sigh. Now, the reason why we found this user was only because of this tweet, because it had hashtag Hurricane Sandy. Everything else was invisible to us. We weren't searching on any of those terms. For instance, that term, or deer. We're not searching on those terms, right? So our colleagues who do research like this on social media, it doesn't matter if it's crisis informatics, but any domain, they're making a query and getting back tweets that match the query. And then asking, is this tweet useful or not? But these tweets appear in a conversation, and whether this one is useful might depend on what was here or what was there. And no, never says evacuate, but finally says, can I head back home? And then says, it's great to be home. So we know he evacuated, but you could only discover that after having read the whole conversation. And so we need, in our social media research, to be much more aware that there's way more information out there that needs to be considered when you ask, is this tweet useful or not with respect to a research question? The problem is, as I indicated at the first half of my talk, it's really hard to develop these things, to find this contextual information, to find all the conversations. And a lot of our research has been exactly that. How do we get this conversational view? And with that, I will say thank you. There's lots of people here that have contributed to this work on Professor Laisha Palin's side, several students there, and my own team of students here. So thanks very much for your time.
So we have time for a question or two. Anybody? Question or two? Question or two?
Yes.
So please, Dale, ask your question.
It seems to me that if Twitter is down for whatever reason, or some point the cell tower goes down and suddenly the people in that area no longer tweet. And to infer things about the state of the network tweet, because that is something that the FCC, as you know, has tried to cell towers around the country down.
Right.
You may be getting on Wi-Fi, but you may not be getting it on. So is there been any use of data to try to infer the status of the infrastructure?
It's interesting because we would actually like to do that. We've talked about that, where if an area of the region is not generating anything, that says something. That's signal, meaning that something's wrong in that particular area, like really bad. But in general, for this type of approach that's looking at it through a social media lens, only about 1% of tweets are ever geotagged. So of the 220 million tweets that we have for Hurricane Sandy, only 1% of those are actually geotagged. And so you don't get a huge amount of coverage of geotags across a region in enough time, like that Hurricane Sandy eastern seaboard photo that I did. That was over several weeks worth of tweets doing that. So yes, I think there would be an interesting research project if more things were geotagged, of being able to identify where things are out because there's no signal coming from that area. I think currently the things you were talking about in terms of what you get from cell towers, which ones are up, which ones are down, there are probably other ways of getting that information that would be more efficient. But
whether it's centralized or
right, yeah, who's got access to it, etc. Yeah.
Combination.
Yes.
Centralized stuff that's going on, and what you have is a very decentralized system.
Exactly.
A combination of the two might.
Exactly. And what's interesting there is, though, you would need to have something in place where you're just monitoring what is normal in an area beforehand, so that once the event has occurred, you can say, oh, that's interesting. When it was normal, there was all sorts of tweets coming out of this area. Now there's nothing.
Right? I won't continue this, but the FCC actually does that before the Super Bowl. They go out and measure the radio environment and see what's signals. And then during the event, they see if there's anybody operating illegal. This signal wasn't there before. Now it's there. Is that person licensed to be on that? So it's sort of the same.
Yeah, same sort of thing. Well, you have to have a baseline to do the comparison.
Baseline.
Exactly. Well, thanks, everyone.
Thank you again.
Thank you.
I like it.